Hey Quincy, this is the assignment. I'm going to go ahead and just basically take your email to me and go through this, and then that way you'll have a video to be able to help you through. So the first one is I'm going to give you this concept: 16 and to the 1/4. What your brain normally does is it says, "What does that mean?" Well, let me explain. So if you have like 3 to the second, that means 3 times 3. You know that that's how it works. If you say 3 to the negative 2, it doesn't mean there's any negative numbers on there. It just means that it is going to be 3 times 3, but on the denominator. So whenever you see a negative exponent, that just means it's simple, it's negative. And it's a thing. When you see a fraction, so let's say, for example, 9 to the 1/2. What that means is it's you can use the fraction rules and all the other rules that you use on exponents, but you really have to ask yourself, what does it mean? A fraction means a square root sign. Okay. And if it's a 2, it just means it's a square root. If you have something like, so this is that. 9 is the square root. Now, if you have something like, let's say, 8, and you want to the 1/3, that's going to mean, I'm going to change my lighting here real quick. See if that helps. A bit better? Yeah, it's a little bit better. Um, and make it a little bit closer. There we go. That's. I think you can read that better. Um, anyway, so 1/3 instead of a square root, what you're looking at is you're going to be looking at, you want what's called the third root of 8. What does that mean? Well, what does the square root mean? Square root means what times what gives you 9. So if you say the square root of 9, you're saying what two numbers multiplied together gives you 9. So the square root of 9, well, that's 3 times 3. And so square root of 9 is 3. Okay. Also, the square root of 9, and that's how you would typically say it. The third root is going to be asking yourself the question. There we go. That's better. Sorry. I was trying to figure out why this thing was not focused. So I'm going to make it a little bit better, a little bit easier to read. There you go. The third root is you're asking yourself what times what times what is 8. That's what third root means, is what's the number if you multiply it together. In this case, 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So the cubed or third root of 8 is going to equal 2. Now, sometimes you will see this written as what is the, um, uh, anyway, a different thing. So, for example, in your example here, 16 to 1/4, is you're saying what times what times what times what is 16? Well, 2 times 2 times 2 times 2 is 16. So that means the fourth root of 16 is 2. That's that number. That's all that means. The fourth root of 16, or you can say 16 to the 1/4. That's what the fourth root means. Now, you have a next problem on here, which is 25 to the 3/2. What you have to do here is you have to know the kind of the multiplication deal, is that this is the same as 25 to the 1/2 times 25 to the third. Oh, sorry. Let me back up. Sorry. 25. Let's put it this way: 25 to the 1/2 and 1/2 times 3. See that? 25 to the 1/2 to the third power is what that means. So you basically separate this into two parts. So you would say, well, what's the square root of 25? Well, what times what equals 25? Well, that's 5. So that part here is just 5. And 5 to the third, in other words, square root of 25 is 5. To the third is just 5 times 5 times 5, which is equal to 125. So when you see one that's got a mixed fraction here, where it's got 3 halves, what you need to do typically is you figure out the fraction part, and then to that power is the answer. So let's say, for example, I've got, I'll use one of my easier examples, 4 to the, let's go 5 halves as an example. 4 to the 5 halves. So what you do is you say, well, that's 4 to the 1 half, whatever that is, to the 5th power. Y'all see that? 1 half times 5 is 5 halves. So 4 to the 1 half, or what times what is 4? Well, that's 2 to the 5th power. And that's equal to 2 times 2 times 2 times 2, which is 32. And that's how you do those. So that's how you do the beginning ones. Is you just recognize that they are in fractions, and you just deal with it that way. Sometimes you see sums that are like the square root of 2 to the 4th power. Well, 2 to the 4th power is 2 times 2 times 2 times 2, right? Which is 16. What's the square root of 16? 4. Okay, it's the same as 2 to the 4 halves. That's what that means if you put it in fraction form. And you do it the same way. You just treat them as separates. Always do either the multiplying out first and then do the other one, then do the square root, or do the square root first and then do the multiplying out. Sometimes you do it one way, sometimes you do it next way. That's how you do those. All right, new stuff. You also had some questions like, what's the domain? Remember, domain means x goes from where to where on this function. Well, generally, the domain means what are the possible x's. So you have one here, problem A, where it says, okay, here's a formula with x's in it, and it goes from x plus 2 times x plus 3. Is there any limitation on where you put x's? And the answer is no. It goes from negative infinity to positive infinity, 0 in the middle. That's the domain. And so you want to write that in interval. In other words, there's no limit on the lowest x and no limit on the highest x. So the way we do that is we say, well, since we don't know what infinity is, we use the curved parentheses and we say negative infinity, comma, positive infinity. That's now an interval notation. Okay, you have another one, E, where f of x is equal to this x minus 2 times x minus 3 over x plus 2, x plus 3, and x minus 5. Okay, so you have this fraction, and you say, okay, is there any limitations on what x can be? Well, you can make x anything you want, and that'll be fine. Anything you want, that'll be fine. But if you look at the denominator, remember, denominators you cannot equal 0. So if x was equal to 2, not a problem, but what if it's equal to negative 2? Well, what's negative 2 plus 2? The answer is 0. So x cannot equal negative 2. If x was negative 3, that wouldn't work. So x can't equal negative 2 or negative 3. And if x was equal to 5, 5 minus 5 is 0. Anything that would make the denominator 0 is 0. Now, if I look at this on a number line, which is the easiest way to picture it, 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, negative 2, negative 3, is what I'm looking for is anything on this number line is good. Well, how do I write that in interval notation? Well, I'm going to go from infinity over here all the way up until negative 3. Then I'm going to have everything in between, then negative 2. Then I'm going to have everything here except for 5. And then I'm going to have everything there. So that's going to be kind of how that looks. So now I just write each part as interval notation. The first part goes from negative infinity to negative 3. But I don't want to include negative 3. So, um, sorry, it's curve. Everything up to negative 3, but not negative 3. That's why I use a curve. And I also have from negative 3 to negative 2. Those are okay. And I have from negative 2 to 5. Those are fine, but I don't include negative 2 or 5. And then I have everything from 5 to infinity. So that's, yeah, I've got this and this and this and this. Those are all the things that work. You can use, you don't have to use the words and. Sometimes they'll use the words or, and that can confuse you. But that's how you do it. You're looking in the denominator to see if there's anything you need to know. Okay, then let's look at the last part of that worksheet you gave me, which is absolute value stuff. So you have A is absolute value of 4 plus 5 minus 7. Okay. Well, what's 4 plus 5 minus 7? 4 plus 5 is 9. 9 minus 7 is 2. So this is equal to the absolute value of 2. So what is the absolute value of 2? It's 2. It means how big is 2? 2 is 2. That's the answer. 2 is just 2. So you can treat absolute values kind of like parentheses too, as far as the order goes, PEMDAS. That works fine. Okay. You have another one that says like C, where you say, okay, 4 minus X, parentheses, our absolute value, if X is greater than 4. Okay, so if X is bigger than 4, that means it would be like 5, 6, 7, and 8. The absolute value of this is going to be, well, let's look at it this way. If X is bigger than 4, basically I'm going to think of this as, I'm trying to wait and think. Here's what you want to be looking at. I'm going to say 4 minus X, absolute value, equals Y. And I want to graph that. What that means is that if I was going to graph this, well, what is 4 minus X? Remember, this is a line. Or think of it, Y equals something times X plus something. Well, this is going to be Y equals negative X plus 4. Okay. It also could be Y equals the opposite of negative X plus 4. What do I mean by that? Remember, the absolute value means that you're, just like I would say, okay, if Y is equal to the absolute value of 2, that just means that Y is going to equal 2. Okay. But Y could also be, sorry, I'm going to use 2. That's going to confuse you. Let's say if Y is the absolute value of X. Well, if X is a positive number, then just Y equals X. If X is a negative number, then what's the absolute value of a negative number? It's also X. So instead of writing the line, if I was going to draw this, I would say that Y equals X is a line for But then when x is negative, y is also positive. It kind of looks like this. Absolute values will typically look like that. Well, in this case, this is my line, intersects at 4, and a slope of -1 goes like this. Okay, so but y is only equal to the absolute value of this. So if x is bigger than 4, what's that going to do? Well, if x was 4, look what happened. What's 4 minus 4? 0. So at x is 4 here. What about if x is 5? What's 4 minus 5? Well, it's -1. The absolute value of that is +1. It's going to go up, start going up this way. So what this graph is going to look like is this. So the question is, what is the solution? The answer is if x is bigger than 4, then what you're looking at is you're saying then y. If x is bigger than 4, then x is going to equal y. If x is less than 4, it changes this a bit. So it's kind of what they're getting at is they're saying, depending on x, what are these things? And you kind of have to draw a picture. I think that's really what they're looking for when they say compute the following. If that's not, if they're actually asking you to solve it differently, I'll have to show you when we get together, because I need to look at specifically what they're trying to say, so that way you get it right on the test. But that's pretty much what they're looking at. Is they're saying, well, draw the formula, draw what it is, and then just say, well, what if it is? Look at the equation or look at the graph, and then go from there. So that's that. That was on the worksheets. Now the lecture 2 talks about polynomials. What it means is that saying anything with an x in it is a first degree polynomial. So y equals x, y equals -3x plus 7. Those are all lines. First degree polynomials are lines. Second degree polynomials is anything with an x squared. And you could have an x, and you could also have a number. And I'm going to say here, you can have x, c represents a number. So you have an x and a number. This case doesn't have one. This case it does. X squareds and x's and numbers. If it's got an x squared, it's a second. If you were to draw it, again, that's a line. This is a parabola. Third degree polynomials are going to be anything with x cubes. They could have an x squared, they could have an x, and they could have a number. They could have just one, or they could have all those, but they have to have an x cubed to be a third degree polynomial. Okay, the number in front of the letter is called the coefficient. That's just the number. Okay, this is a term. This is a term. So that's the vocabulary. So if I have something like 3x squared plus 2x plus 7, and that's equal to y, or equal to my function formula with x in it, and I were to ask you what degree polynomial, it is a, look at that letter, it's a second degree polynomial, because second degrees have x squareds. It has 1, 2, 3, it has 3 terms. Okay, the coefficient on this is 3. The coefficient on that is 2. That's just a number. It's not a coefficient. So the number in front of a letter is called a coefficient. Okay, so that's the first thing. Then the thing that goes with this is you can only add similar terms. In other words, 3 dogs plus 2 cats is equal to y. Okay, so what if I were to say I have 3 dogs plus 2 cats. That's really weird to write it that way. I'm going to write 3D plus 2C. Can I reduce this anymore? The answer is no, I can't. What if I were to say, okay, I've got this plus 7 dogs plus 4 cats? Can I do anything with that? Yes, I can combine the dogs to give me 10 Ds, and I combine the cats, and I have 6 Cs. Now it's reduced. So when I'm adding them together, that's what I'm doing. Well, the same thing in polynomials. And they don't deal with dogs and cats, they deal with x's and y's. So let's say I have x to the third, 3x to the third plus 2x to the second plus x minus 7. And I want to add to that 5x to the third plus 6x plus 10. Well, if I think of it this way, I can only add the dogs. That gives me 8. The cats, well, I only have 2 of those. The hamsters, well, I have 7 of those. And the numbers, well, I have 3 of those. So you can only add similar, or what they say is like terms. Like terms means that they have the same exponents. And you can add 3 of those, 3 dogs, and 5 dogs is 8 dogs. 2, there's nothing there. 1x plus 6 x's is 7 x's. So that's how you do that. That's how you remember to do it, and that's how you add and subtract polynomials. Now, next one, multiplying polynomials. Okay, this is remembering this concept. If I have 7x plus 2, I'm using the distributive property. I'm saying 7 times x plus 7 times this, 14. That's the distributive property. If I have two things, let's say I have x plus 3, x plus 4, what I do is the same thing, and I just kind of take the first one and say x times x is x squared, x times 4 is plus 4x, and that's that one. Then I take the second one, 3 times x plus 3 times 4. Times 4, which is 12. Okay, and then notice I've got a cat, 2 dogs, and a hamster. So it's x squared plus 7x plus 12. So that's how you multiply polynomials. Is if you have a parentheses with a bunch of junk, this plus this minus this times this plus this minus this plus this, is we use the distributive property. We just take the first one times that plus the first one times that plus the first one times that plus the first one times that, and then we go to the second one. Second one times this, second one times that, second one times this, second one times that. And we take the third one, this one times that, third one times that, third one times that, third one times that. So that's the examples you have in your notes, is how to add or subtract. The easiest way is just, again, the distributive property. Your notes say, well, what about the FOIL method? Well, the FOIL method is if you have this, say, and they say multiply this out, I would normally say, okay, it's the first one times this, x squared. First one times this, minus 3x. Then the second one times this, 4x. Second one times this, minus 12. Okay, and then shrink them. That's how you would normally do it. Okay, the FOIL method is similar to that. I'll do that up here. And FOIL stands for first, inside, or sorry, outside, inside, and then last. FOIL. Okay, so if you have this, say the same problem, x plus 4, x minus 3. This only works if this is a 2b, 1, 2, and this is a 2b, 1, 2. So we would say first one's x times x squared. Outside, x times this, minus 3. Inside, this is the inside. So think of this as the outside of a house, and these things are in the inside. Inside, 4 times x. And then last, 3 times 4. And you'll notice that this is exactly the same as what I did there. It's just you're thinking inside, outside. I don't like to use the FOIL method, or in other words, use the term inside, outside, last. It's a 2b, another 2b times a 2b, as opposed to a 3b times a 4b. If you just think distributive property, the first one times every piece, second one times every piece, third one times every piece, you can have them as big as you want. FOIL, inside, outside, last, only works if you have a 2. 2 here and 2 here. If you had 3 here, you can't use FOIL because there's no inside and outside to deal with. So that's a FOIL method. Okay. Factoring, there's some special things, special types of factoring. Some you do, some you don't. If you have something squared, they call it a squared minus b squared. You should be recognizing that that's a common one. That one is very unusual. You have a perfect number that's squared, a perfect number that's squared. That's always going to be a plus b times a minus b. So the idea on that is that you recognize it. So for example, 25, which is a square number, minus, let's say, x squared. Okay. In this case, that's a perfect square. That's 5 times 5, right? This is x times x. So that's going to be 5 plus x times 5 minus x. So the idea behind this one is that you see this and you recognize it and you go, oh, this plus this minus this. That's the idea. So factoring it, this is one of those where I talked to my class about the 30-second rule. This is the 3-second rule. Oh, that's a perfect square. That's a perfect square. In other words, that's something times itself. That's something times itself. I can automatically just go d. There's another common one where you have something to the third power minus something to the third power. Well, that has a very specific pattern you just memorize. You don't care how they got it, but that's going to end up being this minus this times the first one squared, okay, plus that times that, AB, plus this one squared. Okay, and you just memorize that formula. And that, how that might be is, for example, let's say you have x to the third minus 8. X to the third is x times x times x. So that's a perfect cube, right? 8 is 2 times 2 times 2, right? So first of all, figure out what a and b are. In other words, what is it that's going to the third power? What is it that's going to the second power? So this is going to be x minus 2 times x squared plus this times this, 2x, plus this squared, just 4. And so you don't have to try and have any great brain in it. This is one of those where you just memorize that if you see something like this, it fits that pattern. So your example in your note says, for example, you have 8x to the third minus 27 x to the sixth. And it says factor those. Well, this is going to be 2x times 2x times 2x, right? 2x times 2x times 2x. Okay, so that's your A. 27x is 6. So this is 3x squared times 3x squared times 3x squared. So 3 times 3 times 3 is 27. X squared times x squared times x squared is 6. So we would look at this and we say, okay, that's my B. So it's going to be A minus B, 2x minus, this up, 2x minus 3x squared times a squared, that's 4x squared, plus this times this, that's 6x to the third. 3x squared times 2x is 6x to the third, plus whatever that is squared, which is 9x to the fourth. So this is one of those where you have to just recognize that's a perfect cubed, that's a perfect cube, figure out what that is, and then just put those in the spots. Okay, and that's that. There's another one that's very similar, which is a cubed plus b cubed cubed means just to the third power, and it has almost the same formula as this one. The difference is it's a plus b. So how do you know which formula to use? The one that has minus has the minus. The one that has plus has the plus. The same over here, a squared, ab, b squared. But this is where you have to do a little different. If you have this plus this, then you have minus sign in that spot. Everything else is plus. So the difference between the two is where the minus sign is. This one, the minus sign's up here because it's a cubed minus b cubed. This is a cubed plus b cubed. That one has a minus sign there. So you just have to memorize that. There's no shortcut to it. The same way you can, one more is if you see something in this pattern, a plus b squared, that's going to be a plus b times a plus b, right? Using my distributive property, that's a times a squared, plus a times b, plus a times b, or b times a, either one, plus b squared. So this fits into the pattern where if you have a squared plus 2ab plus b squared, so it works kind of both ways. If you see this pattern, this, you can go backwards and hit that one. Okay. See anything else you need to know from this? That's pretty much it. It goes into saying one more thing on here, and that's how do you factor these things? So let's say you have 2x squared plus 7x plus 6, and they say factor. I look at that and I think the 20-second rule, I can't do it. And they give you this big chart on your notes. Forget it. Don't worry about it. Do the quadratic equation. Negative b plus or minus square root b squared minus 4ac over 2a. So I'm going to solve this one, or I'm going to factor this one. Watch what happens. I'm going to get negative b is negative 2 plus or minus, sorry, negative b is it's negative 7. Sorry, there's b. Negative 7 plus or minus the square root of 49, that's b squared, minus 4 times a, which is 2, times c, which is 6. All that over 2 times 2. 4 times 2 is 8. 8 times 6 is 48. 49 minus 48. So I have negative 7 plus or minus the square root of 1 over 4. So what's the square root of 1? 1. So it's negative 7 plus 1, or plus or minus 1 over 4, or negative 7 plus 1 over 4, and negative 7 minus 1 over 4. So I have negative 7 plus 1 is negative 6 fourths. Negative 7 minus 1 is negative 8 fourths. I can reduce that a little bit to negative 3 halves and negative 2. So, and if they say, now factor this, and what you're trying to get is to the factor, I want you to see something cool here. This is what is the solution. Say find equals 0. Those are the roots of that parabola. If they say factor, once you find the roots, you can actually go backwards and write this. So in this case, it's x. Okay. And I'm saying, what if this is 0? What would have to happen for this to equal 0? That's if x was equal to negative 3 halves. So think about it. Look at these numbers. The denominator will go there. The numerator, the opposite, goes there. As I'm saying, this equals 0. Because what's 2x plus 3? If that equals 0, well, subtract 3 from both sides. I get 2x equals negative 3. And divide both sides by 2. I get, let's try this again. So if I said this was equal to 0, 2x plus 3 is 0, 2x equals 3, 2x equals negative 3 halves. So since I know that's the solution, I'm kind of just going backwards to get to this. Let me give you again, shorthand, you don't really care about that so much. If the question is, factor, that's the answer they want. They don't want this. That's the solution, or where do they cross the x-axis, or what are the zeros? But if they say factor and they don't want you to do anything else, you have to go ahead and get the solutions and work backwards one step. And again, the way it is, the denominator goes in front, the numerator goes here. Well, again, what's the other root? The denominator goes in front, that's a 1. The numerator goes second, and change the sign. This is now factored. That is infinitely faster than anything you could do from your notes here. Let's see if I can see this. And almost, not quite. Anyway, on your notes you sent me, the big old chart, that chart thing, that's a pain in the neck. This is way faster. It's 30 seconds to get the roots, and then just write it backwards. So that's how you do that. That's how you factor it. If it's not easy, if it's not the 30-second, what times what equals what. Completing the square is another complicated way to do it. I can show you how to do that one, but I don't think it's necessary because nobody completes the square ever. And then the third one is the quadratic formula. Everybody automatically goes through the quadratic formula. So there you go. Now that's a review. Take a look at that, try the problems, and then get back to me, and we will probably be much more efficient that way, having you tried it with a little bit of explanation.